Hi and Assalamualaikum warahmatullahi wabarakatuh to the panels. My name is Dzul Idham bin Nasri with metric number DE200133. Going to present about my final year project 1 presentation, portable filtration with IoT-based water quality monitoring system for aquaponics, supervised by Associate Professor Engineer Dr. Hanis binti Mohammad Radzi. So this is my table of content, starting by introduction, followed by problem statement, until the conclusion. I will go for the introduction. The most efficient technique of hydroponic and aquaponics is called nutrient film techniques. This mechanism makes it possible for plant roots to acquire sufficient nutrients, water, and oxygen. In addition, in NFT also use two main filtration, which are the mechanical filter, which means a physical trap to settle fish solid waste, and the biological filter to convert ammonia into nitrate using nitrifying bacteria. So the figure shows the radial filter, mechanical filter, biological filter in NFT. The goal of the project is to construct a portable filtration for the mechanical filter for an aquaponic system and to provide an IoT water quality monitoring system as aquaponic water quality checker. So for the problem statement, it shows three root cause, which is the first one, the traditional filtering system. It can difficult to do maintenance and influence water quality. When influence water quality, it produces the root cause number 2, which is poor water quality, and the effect is the fish production will decrease, plant growth will also be stunted. So the root cause number 3 is no automation system in order to monitor water quality in the aquaponic system. So for the water score, users only observe by their eyes for the turbidity of the water and the rate of dead fish or tree fertility to measure the level of water quality in the system. So for the objective, there are still three objectives, which is the first one, to design and develop user-friendly portable filtration for the aquaponic system. The second one, to implement the IoT monitoring system as a water quality checker in aquaponics named PonicsMon. And third one is to analyze and measure the important parameter in monitoring water quality before and after project implementation. So for the scope implementation, they have four scope, which is use NFT techniques. The area of study is on the UTHM aquaponic system, and the third one is the innovation of portable filtration are limited to mechanical filter only, and the fourth is the four main parameters will be implemented for IoT water quality monitoring system are temperature, potential hydrogen pH, turbidity, and the TDS, total dissolved solids. So for the literature review, I will start for the three parts of literature review, which is the first one is the aquaponics. Aquaponics involve growing plants in a variety of hydroponic system. The NFT is one of the most common design for small-scale aquaponics. In this arrangement, the plant roots are suspended in various shape channel through with a thin layer of nutritional solution flows. And for the purpose of the mechanical filter as a solid removal by Mulansis et al. And filter can improve water quality by Esteem A et al. And waste converting to non-toxic form by Nelson RL. So for the water quality in aquaponics, there are 5 important water quality parameters need to be measured on aquaponic system, which is the first one is dissolved oxygen, total nitrogen concentration, pH level, hardness, and the water temperature. So this is the previous study on the aquaponic mechanical filter. So the first one is Swill separator filter and radial flow filter by David J et al. So there is a traditional filter and there is no user friendly. There have a big size of filter and not easy to maintenance, not included by filter and less improved water quality, and followed by rough filter using Matala media by Matala products. There's innovation from the previous one, and there's no user friendly, and it's a quite big, not easy to maintenance and include by filter and less improved water quality. And then continue by biocar filtration by KS. There's innovation from the previous one. There have no user friendly features and have a big size, not easy to maintenance, and include by filter. And the fourth one, the propeller wash bed filter, use the bed filler by Pesifir T et al. There's innovation from the previous one, and there are user-friendly features, have a big size and not easy to maintain. And the fifth one is the portable dual-purpose water filter system by El Harbawi 2010. There's innovation from the water filter previous, and yes, there have a user-friendly features, small and compact, and improve water quality. So for the Aquaponics IoT water quality monitoring system related words also have state 4 related words, which is the first one, automated water quality monitoring system for aquaponic. The method used is they can use the ammonia concentration test and also use the blink application. And the second one is the IoT-based water quality monitoring system for aquaponics by Mohammad Buain, and he used microcontroller as the Arduino Nano and use web application as the IoT application. The device can measure the pH level only. And the third one is IoT-based water level monitoring system for a lake in a cloud environment by Datlani et al. 2019. She used the Arduino Mega in the microcontroller, and also by the web application, the device just can measure the pH level, hardness, and water temperature only. So for the smart water quality monitoring system using Wi-Fi by Satish et al., they're using the SP8266 Wi-Fi module and apply for the phone application. The device can measure the DO test, pH level, and hardness only. So for the literature review summary, based on the literature review, the project have set some limits to the project. Firstly, on the filtration side, the project can use several filter media or material that have been used in previous studies such as cocoa shell, coral stone, and others. The second one, the filtration part must follow the project objective, which is portable and easy to do maintenance. And the third one is the aquaponic IoT water quality monitoring system. The device can measure the quantity of pH level, water temperature, turbidity, and total dissolved solid only of the water. So we go for the methodology research. Methodology research guided and followed by the project flowchart. This flowchart elaborate the flow of overall progress in this project. So the first one, go for the literature review, do site visit, system designing, prepare the material, implementation. So I have divided by phase. The first phase is system designing. The second phase is system implementation. The third phase is performance and evaluation. And the fourth phase, analysis and discussion. In FYP1, I have done until phase 2, which is phase 1, which is the system design. For the filtering system operation, this is the material gonna use in the filtering part, which is the first one, mesh fluid. It can be used in many applications such as sanitary pipe system to remove contaminants. Second one, sponge. Filter water through the sponge, trapping particle and pushing only clean water out to the top of the water filter. Coral stone. Due to its porous nature, fossil coral may absorb contaminants including bacteria and others. Cocoa shell, seashell as biofilter to remove odorous substance in physical and chemical evaluation. And for the activated carbon, can use more in filtration. The activated carbon also is special and adaptable absorbent that is widely used to remove unwanted flavor, color, and other organic and inorganic contaminants. And for the silica sand, water filtration system have long employed silica sand to provide the final touches to clean water. And zeolite, highly porous nanoscale cage in zeolite crystal formation may filter and trap tiny molecules. And the last one, mineral sand, which is because it adds the minerals to the water. Mineral sand is utilized in water filtration. It changes the water's pH to a slightly alkaline state. So this is figures of the filtering media. And we go for the aquaponic IoT monitoring system operation. The left side is the flowchart. The right side is the block diagram. For the block diagram, it will shows the use the 4 sensor, and for the microcontroller it is Arduino Uno SP32, and also for the output it shows the LCD display and the blink application act as IoT monitoring. So for the flowchart, starting by start, sensor read, and go for the Arduino read the analog and digital signal from the sensor, and go for Arduino send the data to this LCD display and blink. If no, it will go for the sensor read again. If yes, initialize the Wi-Fi module, ESP32, blink app shows the sensor measurement, and go for the continue loop, which is if yes, it will continue the loop, and if no, it will stop the operation. And this is a component which is for the sensor, pH sensor to measure hydraulic ion activity, pH level, temperature sensor to sense any physical change to Aquaponics water temperature in digital output, analog turbidity sensor to measure the amount of light that is captured by the suspended solid in water, and the last one, the analog total dissolved solids TDS sensor to indicate the total dissolved solid in a solution. For the component used in processor and microcontroller, we use 2 types, which is Arduino Uno and ESP32. So for the Arduino Uno, to process the data from sensor and generate it to the output, which is the LCD display. And for the ESP32, act as Wi-Fi module to process data from Arduino Uno and display wireless on the phone. So for the output, there are 2 types also, which is the I2C LCD display to display the value of pH, temperature, turbidity, and TDS sensor on site. So for the blink application via Android to display the value of sensor and on the phone by wireless. So for the preliminary result, we show the design of portable filtration, the design of Ponixmon, the circuit design of Ponixmon, and the pH and temperature sensor calibration result. So this is design of portable filtration. The design is including for the cylinder acrylic, and maybe provide some material in 3D printing for the plastic top and bottom of the filter. So this is the arrangement of filter media, following by the methodology part, which is using the filter media. And for the design of Ponixmon, this is the design of Ponixmon. The first picture is the Ponixmon device, and the second picture is the water surface casing, which is it can float to the water, and the third one is the casing for the when to measure the water quality on the biofilter. So this is a total system. The system when it applied to the Uthm Aquaponics system. And for the schematic of Ponixmon, this is the figures, shows the schematic, including the sensor, the microcontroller or processor, and the output, which is the LCD display. And for the calibration result, we use only 2 because not have time to buy another sensor, which is the temperature sensor and the pH sensor. For the temperature sensor, we have calibrate for the 2 types of liquid, which is the ice water and hot water. So for the ice water, the temperature shows 2.5 degrees Celsius. For the hot water, the temperature shows the 69 degrees Celsius. And for the pH sensor calibration result, this is a result for the lime water, distilled water, and softener. Lime water we know as acid, and the pH value shows 5.3. Distilled water shows 7, which is the neutral, and softener the pH value shows 12.4. And this is my future plan for my project, which is the first one is do the hardware installation and prepare the prototype, which is filter and the Ponixmon. And the second one, do the testing on site before and after implementation, get the result on effectiveness of the system in 7 days in average. And the third one is able to monitor on Blink app, which is to monitor in some distance. And the fourth one, which is test on filtration side, either it is portable and easy to do maintenance or not. And this is my Gantt chart, PSM1, which is starting by a briefing until designing the system and submit the PSM1 report. So for the conclusion, the project will continue to the FYP2, which in progress to implement the system. FYP1 have a further research on particular part on and fully explained in literature review and methodology. And for the final result on testing and calibration will be presented after implementation, which in FYP2 later. Thank you, that's all from me